Okay, this comes from a puzzler on Car Talk. Actually, it was a caller who called in with this problem. I'm going to solve it here. Basically, he said, okay, consider a cylindrical gas tank. It's lying down or it's horizontal, and we want to have a dipstick that will tell us when the tank is 3/4 full. So, if the tank is 20 inches in diameter, what would the height of the have to be, what would this h have to be when the tank is 3/4 full? So you can see it's not just a straightforward geometry problem. The only way I can think of doing this is using calculus. So let's draw this up on our Cartesian coordinates, and what we're going to do is we're going to solve it the other way. Okay, so we're going to take an integral, and remember, an integral is the area under a curve, so we're going to draw a quarter of a circle, and we're going to integrate from x equals 0 to a, where a is this special distance at which half of the area is on the left and half is on the right. So here's the integral, okay, where we have some function f of x which describes the height of the circle at each point x, and we're integrating from the limits from 0 to a. And we know the area of this section because what it is, it's just half of a quarter of a circle. So that's pi r squared over 8. So the only thing we need to do is plug in for f of x. So what is f of x? Well, let's start with the equation for a circle. So with a radius of 10, we get 10 squared equals x squared plus y squared. Okay, so the only thing we need to do is solve for y, since y is the height at any position x. So there we are. We have f of x is equal to y, which is square root of 10 squared minus x squared. So we've just solved that for y. So we need to plug that into this integral and then integrate it. Now that's not a straightforward integral that you can do in your head. The way I did it was to look it up in a table of integrals. So I found it there. There was one that looks like a square root of a squared minus x squared. So I just plugged in for that for a equals 10, and so I get the I'll just write down the antiderivative here. Okay, so that's the equation I got from the handbook. So we have two terms here. We have a square root term, and then we have an arc sine term. And remember that arc sine it means the angle whose sine is x over 10. Okay, so all we need to do is just evaluate that expression at these two integration limits, and we'll start with the lower one since it's easier, because the left side is just 0, and the right side, arc sine of 0. What is that? Well, at an angle of 0, the cosine is 1 and the sine is 0, remember, from trigonometry. So we have both terms equaling 0, and so at the lower limit we just have 0, and the upper limit is the only thing we have to worry about. And so all we have to do is plug in a into that equation and set it equal to this pi r squared over 8. Here we are. Okay, so now we have an equation with one unknown, so we can just solve for that unknown. But looking at the equation a little bit, we can see that it's not a straightforward equation to solve. We can't get a closed algebraic form for the answer for A. What we have to do is solve this numerically. And there are various ways to do that. Some are more elegant than others. But what I'm going to do is just go and paste this into a Google calculator. I'm going to shift this term over to the right-hand side so it will have a negative sign. And so I'm just going to plug in by trial and error, various values for A until everything over here gets close, somewhere close to 0. Okay? So let's try that. So here I've pasted it in, and I've put a starting number for A, which is 4. Why did I choose 4? Well, 4 is a little bit less than 5, and so we know it should be something less than 5. So 4 gives us something rather close to 0, but it's a little bit below 0, minus 0.36. So let's see if we can do a little bit better than that. Should we go up or down? I'm not really sure. Let me go up. My instinct tells me to go up. Okay, so it's recalculating. Yeah, it is going up. So let's put in 4.1 for everything. And let's see what we get. Okay, good. So now we're too high, so let's just split the difference. 4.05. Okay, we're pretty close to 0. Let's go with that. That may be we may need only 3 digits to design this gas tank. But if we wanted to spend a few more minutes getting a few more, it wouldn't be too hard to do so. So we'll just plug in 4.05 over here, and so we have A equals 4.05, and now we have to get H. Okay, so H is just from here to the middle, which is 10 inches plus 4.05, right? So H is equal to 10 plus A equals 14.05 inches. And so that's the height of the tank when it's 3/4 full. There's one more thing that we can try, which is to check to make sure that we got our math right. Okay, so make sure that we didn't make any mistakes in getting this integral and looking up in the handbook. So what we can do is just do a sanity check. We can say, okay, let's integrate all the way from 0 all the way to 10. We'll do the full quarter of a circle and see if we get the right area. It should be pi r squared over 4, right? So let's check. All we have to do is plug in x equals 10 into this equation, right? So we do that. This term goes to 0, and so we just have the right-hand side where we have an arc sine of 1. What is arc sine of 1? Well, that's with the angle of 90 degrees, or pi over 2. Okay, so we have pi over 2 there, and then we have 100 squared, and then that 1/2, so we have a 50 times pi over 2. So in fact, that is equal to, another way of writing that is 100 times pi over 4, which is just pi r squared over 4. So indeed, we were using the right equations there, so that sort of confirms that we are on the right track. Great.